Welcome to the Rhythm Tree tutorial series, created by the junior high band teachers of the Gilbert Unified School District in Gilbert, Arizona. Rhythm Tree tutorial number 3, 16th. At the end of this tutorial, you should understand 16th notes and 16th rests, the relationship and differences between 16ths and 8ths, the relationship between 16ths and quarters, and the mathematical breakdown of note and rest values from whole to 16th. To be successful, you need to already understand the concepts taught in these earlier tutorials: Rhythm Tree Part 1, whole and half, and Rhythm Tree Part 2, quarter and eighth. The first two tutorials in this series showed that notes make sound and rests are silent. They also showed that notes and rests of the same type get the same number of beats. The analogy of a rhythm tree helped explain the relationships between different note and rest values by picturing them as leaves on a tree. Starting from the whole, worth 4 beats, the tree branched out into more leaves of increasingly smaller values: half, worth 2 beats, quarter, worth 1 beat, and eighth, worth only a half a beat. This tutorial continues the rhythm tree analogy to introduce the next smaller value of notes and rests, the 16th, and to show the relationship between eighths and 16ths. We've already split the whole into halves, quarters, and eighths. Now, each eighth branch produces 2 smaller leaves of equal size. Each new leaf is only 1/16th of the whole, or 1/4 of a single beat. A 16th note makes sound, and a 16th rest is silent. Here is what 16 single 16th notes looks like. Notice that these have double flags. Remember, a number represents a beat, and a plus sign represents a half a beat. We say "and" when counting the plus sign. New symbols are needed for the 16ths that occur between the numbers and the plus signs. We use the letter E for a 16th following a number, and the letter A for a 16th following a plus sign. Pronounce the A as ah when counting out loud. So in this case, here's what we have: 1 E and a, 2 E and a, 3 E and a, 4 E and a. 16th rests work exactly the same way in counting and symbols as the 16th notes. The only difference between 16th notes and 16th rests are that the 16th notes make sound and the 16th rests are silent. 1 E and a, 2 E and a, 3 E and a, 4 E and a. 16th notes and 16th rests get 1/4 of a beat each. Sometimes 16th notes are grouped together with a double beam. Nothing changes except the look. Rests never get beams. Here we have 2 single 16th notes, or we have double beam 16th notes. Just like eighth notes, the most common way to double beam 16th notes is in groups of 2 or in a group of 4. And just like with eighth notes, we can mix and match the singles and the double beams together in the same measure. It's all the same, it just looks different because we're grouping them differently. The first 4 things we see are 4 single 16th notes: 1 E and a. The next 4 are still 4 16th notes. They're just grouped in pairs: 2 E and a. Then we have 4 16th notes grouped together: 3 E and a, 4 E and a. but the counting is still the same as if they were all single 16th notes. Let's compare 8th notes now to 16th notes. Notice the differences. There are single flags on the stems of single 8th notes. There are double flags on the stems of single 16th notes. 8th notes can be beamed, most commonly in groups of 2 or 4. 16th notes can be double beamed, again most commonly in groups of 2 or groups of 4. 8th notes get 1/2 beat each of sound. 16th notes get 1/4 of a beat each of sound. When counting 8th notes, we count and write a plus sign in between the numbers. 1 and 2 and 3 and 4 and. When counting 16th notes, we count E after each number and after each plus sign. 1E and 2E and 3E and 4E and 2 8th notes can fit into 1 quarter note, but 4 16th notes can fit into 1 quarter note. Now let's compare 8th rests to 16th rests. Notice the differences. 8th rests look like fancy 7s with a dot on the left. 16th rests look like fancy 7s with 2 dots on the left. 8th rests get 1/2 a beat each of silence. 16th rests get 1/4 of a beat each of silence. When counting 8th rests, we count and write a plus sign in between the numbers, the same way we would do it if they were notes. 1 and 2 and 3 and 4 and. When counting 16th rests, we count E after each number and after each plus sign, the same as we did with the notes. 1E and 2E and 3E and 4E and 2 8th rests fit into 1 quarter rest, but 4 16th rests fits into 1 quarter rest. Now let's look at that concept of notes fitting into each other. So 2 8ths fit into 1 quarter. That means that 8ths are twice as fast as quarters. If you look at the example here, you'll see that we only have 4 quarter notes, but we have 8 8th notes that have to fit into the same amount of space. And when we add the counting and the plus signs, it becomes a little more obvious. 1 and 2 and 3 and 4 and. 4 16ths fit into 1 quarter. That means that 16ths are 4 times as fast as quarters because we have to fit 16 notes in the space of 4. Notice how the counting lines up. 1E and 2E and 3E and 4E and So let's look at the complete breakdown of the math for all of these different note types. We start with the whole, worth 4 beats. It's our whole amount. It's the biggest leaf on the tree. So a whole note gets 4 beats of sound, and a whole rest gets 4 beats of silence. We then take our whole and we split it into 2. So now we have halves. A half gets 2 beats because it's half of the whole. So a half note gets 2 beats of sound, and a half rest gets 2 beats of silence. We take our whole and we divide it into quarters. Quarters get 1 beat each because it's 1/4 of the whole. So a quarter note gets 1 beat of sound, and a quarter rest gets 1 beat of silence. Then we divide the whole into 8 parts. An eighth is worth 1/2 of a beat, 0.5 of a beat, because it's 1/8 of the whole. So an eighth note gets 1/2 a beat of sound, and an eighth rest gets 1/2 a beat of silence. Finally, we divide the whole into 16 parts. A 16th is worth 1/4 of a single beat, 0.25 of a beat, because it's 1/16 of a whole. So a 16th note gets 1/4 of a beat of sound, and a 16th rest gets 1/4 of a beat of silence. This tutorial showed that notes and rests of the same type get the same number of beats, and that notes make sound and rests are silent. It employed the analogy of a rhythm tree to show the relationship between the note and rest values of sixteenths. It demonstrated the relevance of quarters to eighths and quarters to sixteenths. The next tutorial in this series will focus on visual representations of the rhythm tree.